Welcome to Presentation 36. Today the subject is going to be the magnetometer, part number GY273. Now the magnetometer is part of our layers 3 architecture. To be able to develop programs and make it basically tick, we're going to need to use the from layer 3 what we learn on displays, servo motors, pulse width controller, joystick, and potentiometers. Now from layer 2 architecture, we're going to be using the UART framework, SPI framework, I2 framework, analog to digital conversion framework, and the IO port framework. Now the agenda for today. So today I'm going to give you a magnetometer description. Then we're going to look at the data sheet, develop from the data sheet a framework. Next, show you how to initialize the magnetometer. We'll go through a sample program, and finally we'll go through the summary. So let's get going. So this is a picture of the magnetometer. The input signals are the voltage, ground, and then this is a I2C unit communication with this unit, so I2C I should say. So we have the SEL and the SDA, and then we have an interrupt line which we don't use. Now this is the other side of the chip, and here you have the X and Y, and that gives you the axis from which it's been measured. And also it has the GY273 utilizes the magnetometer chip, which is this one here, which is going to be the HMC5883L. Now, the GY273 is a digital compass you can connect to your ATMEGA 328. It measures magnetic field in 3 axes, X, Y, and Z. Lets your microcontroller calculate the heading, the direction which is going. Now what it does is it provides the angle and it provides you the X and Y coordinates, and you can calculate the angle of your direction. So and you do it as follows. So you have the heading is going to be equal to arc tangent Y comma X, and that gives you the your heading, this vector. Now uses the I2C communication, the SDA plus the SEL pins like I noted here. So let's go to our data sheet. This is the data sheet for the magnetometer, and my goal is to give you some general idea of the contents of the document, so later on you can come and just review it yourself. And basically this is the document I use to do all my programming and for all the information that I needed. So the first part here, what we have is the some of the features and benefits, followed by the specification, voltage, gains, just the different items that you would need in general to do your connections. Next, in page 8, what we have is a flow of the magnetometer operation. So what we basically, the way it's going to work is we're going to send an I2 message requesting, either configuring the unit or requesting data. Once we send our message, then 6 milliseconds later we're going to get a reply, and then we can do this over and over. So it's just basically a regular I2C flow. Next, let's go to page 11. In page 11, you have the register. To either to configure the magnetometer or get the XYZ heading, or just getting any status, you have to access this register. For example, we have an address 0 and address 1 is going to be used to configure the magnetometer, which is called the register A and register B. Next, in address 2, hex 2, that's where you select what mode you want the unit to work, to do all the calculations. And then following that, you request in register 3 through 8, you request your X, Y, and Z data, so you can calculate your heading with that data. Let's keep going here. So now in this area, what you have is a definition of each of the register. So let's start with register A and get an idea what's there. But with register A, what you can do is you can define what is your output rate and your measurement modes. So the rate here, it shows you what are the parameters you have to set your registers. You can get the different output rates in hertz. And then after that, you have the measurement modes. Next, what follows is your configuration register B. Now with your configuration register B, what you can do basically is set up your gains. And here you have the different values of your register, so you can define what's going to be, what gain you want to use. Now next you have your mode register. The modes, you basically have three modes. The first one is the continuous mode. Next is followed by a single measurement mode. So I should actually say continuous measurement modes. Next, you can set it up as a single measurement mode or an idle mode. And once we get into continue with the presentations, I'll show you what mode we selected and why. Next, we have the definition here. They show you for how to access your registers that have the X, Y, and Z parameters. It shows you what the data format. So that's for the three parameters. Then it shows you how to access your status register. And the other item that I want to show is in page 18, they have the operational examples. I think that's very useful. So the main thing that you want to get from here, it shows you what are the initialization parameters, examples of how you can initialize your magnetometer. For example, they have here one that you can initialize it for a 15 hertz data rate, normal measurement. Then that's for register 0. For the register 1, they say, hey, do a gain of 5. And then finally for the mode, which is register 2, they say go on continuous mode. And then it shows you once you've set up your configure your magnetometer with register A, B, and mode register, then it tells you what to do on your loop, which is basically you are going to request the X, Y, and Z data. So so that's basically what you you have in this document. This is fairly short document. Has barely. It actually has 19 pages, which is kind of short, and it has a lot of very good information, and it's really worthwhile just reviewing it and at least having this document handy. So anyhow, let's go back to the presentation. Okay, so let's continue. So this is the, let's put together the framework. And what I did as usual, I grabbed this from the data sheet, which is the register, description, and name. And for each of the items, I created a some code so we can access those items, so we can modify them. So basically, this is the what's going to turn out to be our framework. So this is our framework code. So basically, we have to how to access configure register A, then configure register B, and then the mode register, which are the three that we're going to use for our initialization. And then another thing here is that register 3, 4, 5, 6, 7, and 8 contain the X, Y, and Z data. And when we request the data, we have to make sure that the way we're going to initialize it, that we put these parameters in this same sequence. So let's look at how we're going to initialize. So we have register A, register B, and mode. So this register A is address 0. Then we have address 1, and the mode is address 2. So the values we're going to use is for register A, we're going to use an average, we're going to use 15 Hertz sampling in normal mode. Then the gain is going to be equal to 5, and we're going to use this continuous measurement. The continuous measurement, the idea is that when we ask for the first register, which would be 3, the system is going to go ahead and send us the whole all the data for the X, Y, and Z. So continuous is going to send X high, X low, C high, C low, and Y high and Y low. We have to make sure that we keep the sequence. So what it amounts to is we get 8 bits at the time, and each of the parameters 16 bits. So we have to get 2 reads for each of the parameters. So this is what the code is going to look for the configuration. So we're going to use the start. That's typical your I2C start. There's nothing magical there. Then we're going to transmit address plus write. The address of the magnetometer is 0 hex 1E. Then the first thing we do is we are going to send the register, and then we're going to send the normal mode, the gain, and continuous mode, and then wait 100 milliseconds. Now the way you transmit the configuration, when you get the GY273, you could get different magnetometers chips on each. Even though you have one part which is the GY273, they could have different magnetometers, and that's going to change how we are going to communicate the initialization. However, the normal mode is hex 70s, hex 0A, and hex 00 continuous mode. That's going to be the same. The only what may change is how you send your plus write and transmission. So let's let's look at the sample program, because as we develop the sample program, I'm going to be explaining how you do each of the things. So what does our setup looks like? So we have our color display. So there's nothing new here. And then we're going to be hooked up to the laptop. And then we're going to be hooked up to the magnetometer, so the I2C bus. So we have SDA and SCL. So as far as the connection with the magnetometer is fairly straightforward. So let's look what we're going to do on sample program 1. So first, we're going to read heading from the GY273 sensor. Next, provide a graphical representation of the heading using techniques learned in Presentation35 display graphics. What I'm requesting here, what we want to do here is we're going to write in the display, we're going to show actually a graphic of how the magnetometer is moving. Next, display a numerical presentation of the heading. So in 2, we present graphically, maybe we're going to have a circle with an arm moving that represents the direction, the heading, and then we're also going to have on the side the actual numerical value. Next, we're going to use a test setup based on technique learned in Presentation34 using basically our 16-channel PWM controller. The idea here that we have this thing to rotate so we can see that it behaves correctly. So we're going to use what we learned in Presentation34 to actually have a test rig which is going to rotate the magnetometer so we can see the output. So let's go ahead and see how we're going to do this. So we need to figure out how we're going to go about calculating the heading using the GY273 magnetometer. So these are basically the steps. First, we need to read the magnetometer value, the X, Y, and Z. Now, we have to read all the data, even though we're only going to use the X and Y to calculate heading. Next, once we have the X and Y values, then we need to calculate the heading, and we do that by heading is going to be equal to arc tangent 2 of Y comma X. Now this gives us a direction in radians between minus pi and pi. Now the first thing we have to do with this data, we have to convert the heading to degrees. So the heading in degrees is going to be equal to heading times 180 divided by pi. Now if the result is between 0 and 360, because our tangent can return actually negative value. So what we need to do is that if the heading is less than 0, then we need to add 360. So the degrees add up. So let's look at the code, how we do that. So what we need to do is we need to get the data using the I2C protocol, using that bus. So we sent the start command to the magnetometer. We actually sent the start command to the bus. Then we transmit the address plus write, basically telling the magnetometer that, hey, we're sending you data. And we send it the data 03 hex. We do that because that's the register where the first value that we're interested in is going to be located. And once we send that, then we have configured the unit in such a way that it's going to send all the data. So once we send the register we're interested, the first register we're interested in reading, next we do a repeat start, and then we send the command that we want plus read. We want the magnetometer to send us the data, and it's based on start point 03 register. So as we configure it, the magnetometer is going to send us the X high, X low. Let me stop here for a minute. Each of the parameters X, Y, and Z, they are 16-bit resolution. So we have to get 2 messages for each value. The most significant, which is the X high, and the least significant, which would be in this case the X low. So we do that for X Z, and Y, and we need to keep this. This is the sequence we have to do it, because that's the sequence going to be sent. So we are going to get the high and low for Z and high and low for Y. Next, we have to concatenate those messages into one. So we have the X value is going to be the magnetometer X value high shifted 8 values to the left, or it with the X low. So that gives us our 16-bit value in the correct sequence. So we do that for X, Y, and Z. So at this point we have the data we need, and that's basically what we done is we read the data values. Then now the next step that we have to do is we have to calculate the heading. So before that, we're going to do a little bit of housekeeping. Basically, we're going to send another start command plus another transmit plus write to the magnetometer, which the address is, I should have said that before, 0 hex 1E. And then we're going to transmit the 03, basically setting the pointer back to register 3, and we stop. Okay, so item number 2. At least we get the data, a little bit of housekeeping, and let's do item number 2 is calculate heading. So that's going to be arc tangent magnetometer Y, magnetometer X values. But what we also have to do is we convert from radians to degrees. So we're going to have to multiply it by 180 and divide it by pi. Now, as I noted before, and if the value is minus pi to plus pi, so we could get a value, negative values. If we do that, then we need to add 360. So I say, hey, if the rotation in degrees is less than 60, then go ahead and add 360 so we can get in the correct coordinates. Next, now that we have the data, so we have the rotation in degrees. Now we have to do two things with that data. One is we're going to send it to the laptop so it can be displayed through our UART interface. So that would be the serial intent rotation, and then we're going to add one line. So that's just to send it to the laptop, and then the next value is going to be in the next line. And we've done that here about 100 times, and I had a presentation on how you do that. And the next thing we're going to do with this data is, so we send it to a laptop, and then we're going to return it to the calling routine. So let's continue to look at another portion of the program. So what we want to do is the magnetometer is going to move around, and we're going to have this arm which is going to show the rotation. So visually you're going to see the arm, and you're going to see how the magnetometer rotates. And another thing we're going to do is we're going to draw a little square here, and we're going to put the actual angle. So you see, like, this is almost 360, so it's 359. So as we rotate, you're going to be able to see pictorially, graphically see the arm move, and you're going to see the numbers. Now, all this we did it on presentation 35. On presentation 35, I showed you how to have this circle and the motion of the arm. So that should be nothing new, but so one thing I didn't do in presentation 35, we drew a square, but I didn't do a generic routine to do that. So I went ahead and did it this time. So the input to draw this particular square is going to be the color of the lines of the square plus the X and Y values of the top left corner, and then I'm going to need the X and Y value, which I call X1 and Y1, of the bottom right corner. So what I did, the first thing I do is I say, okay, X of the top left is X, Y top left is Y, that's this corner here. Now next I say X bottom right is X1, that would be this corner, and Y bottom right is going to be Y1, which is going to be this corner. So with that information, I have enough to draw the circle, the square, I mean. So the line, for example, is going to be this line is going to be top left X, top left Y, is going to be bottom X bottom right, and Y top left, the same Y. So as I go through this, then I have the second line, which is going to be this point is going to be X top left, Y bottom right, and this point is going to be X bottom right and Y bottom right, both. And then I'm going to draw this these two perpendicular lines, which is going to be, in one case, is going to be X and Y top, and X top and Y bottom, right? So anyhow, that's how you draw, and you can go ahead and figure it out. With these 2 points, you can draw the whole square. So now let's look at what would be the main routine for this particular program. And this is just exactly as in presentation 35. So we draw the whole screen with one color. And then we're going to draw a circle. Now we want this circle to be a little bit thicker, because if you do just one line, you can hardly see it. So we're going to send the radius and then the center of the circle to the draw circle. And that's all, again, presentation 35, nothing new here. So 4 circles that have the same center, and what they do is they have smaller radius, so 86, 85, 84, and 83. So I decremented the radius of so I draw all these 4 circles, and they look a little bit thicker and you can see it. Next, we write the hello world that actually comes here, but you can't see it because I write the hello world, then wait 3 seconds, and then I write hello world again, but with the color of the screen. So it disappears, and then I write the in color black. I write the magnetometer, sorry, GY273 at these coordinates. So here we have magnetometer GY273. So that's how, so far what we have is this. We have the circle, we drew a square, but we haven't drawn the arm yet, or the value that goes inside this square. So let's go ahead and write the draw the arm. Now again, this is presentation 35, like 90%. So the input to this routine is going to be the color, the radius, X and Y center. So how we do this? So we're going to have a variable called angle, and that's going to give us the magnetometer data. The data was just calculated in degrees. Then after we get the data in degrees, we're going to do some calculations here, and the calculation require radians. So we're going to change the angle, multiplied by pi divided 180, and that's going to give us our radius, our angle in radius. So basically what I'm looking is to calculate the point right here. So if you look at this point, I'm going to have the X and Y, and then I have my angle. So with the cosine and sine, I can figure out what are the X and Y coordinates. So what I do is X1 is going to be the center right here. Then I have to add the radius times the cosine of the angle, and then for the Y I have to do the same, but then I have to multiply it by the sine of the angle. So the radius times cosine of the angle, and the radius times sine of the angle, and I'm going to give my X and Y coordinates. So once I have my X and Y coordinates of any of these points, then I can draw the line. So basically the line is going to always start at the X center, Y center, and then I already calculated the point on the circle. So I have X, Y, and then then I have my X1 and Y1, which are the values I just calculated. And now I want this circle to be a little bit thicker. So as before, I keep the same center and I just increment the radius. X plus 1, Y plus 1, X plus 2, X plus 3, the same thing from Y. So now I have my 3 circles. Basically, I have my 3 lines, I should say. So I have from the center, I draw 3 lines. So you can see that this is a little bit thicker. Otherwise, 1 line would look pretty thin. You can hardly see it. So I draw 3. Then I wait 300 milliseconds and I erase those lines. It's basically the same code, but what I did is I changed the color. I started with color black and then I changed it to color 1, which is the value of the screen, so the whole thing goes away. So now, so far I have my circles, I have my line, I have my square, but now I have to add the degree in numbers here. Now, this is going to, I want to only change this number if I have a different angle, but because if I do it all the time, this is going to end up flickering too much. So I don't care about doing the rest, it doesn't show, but these numbers really show a lot of flickering. So I'm only going to change them, erase them and put a new one if I have a new angle. So I said, hey, if the angle not equal to the last angle, then I'm going to do stuff. But if the angle that I get is same as the last angle, I'm not doing anything. And then the last angle becomes the angle. I mean, yeah, yes, the angle, the last angle always has the one preceding. So I have the angle is a number, but I know how to put strings on the display. I really don't know, I don't have a routine to write numbers, it's just strings. So the ASCII value, so I need an ASCII value, in this case would be for 3, 5, and 9. So how do I do that? So there is this function, UTOA, is a C function that you put in a number and then a base, which is, so you have 3 parameters, a particular number, a string, and then you have a third number, which is the base. So the way this works is that it's going to take the number you put in the first parameters, and using base 10 in this case is going to put in the string. If I put base 2 here, number 2, then it would put ones and zeros as strings. So it's going to convert the number into a string. It's all in base 10. So once I have that, then what I do is I say, hey, first thing I'm going to do is I'm going to erase the last number I got, and this particular location this matches this point here. Next, once I erase the last angle, which was the preceding angle that was written, so I start with, hey, take the last angle and let's erase it. That's what I'm doing here. Next, I'm going to use the same function but with the new angle. That was the angle. So I'm going to write 16-bit black, size 2, string 2, starting at 61,181. So I come in first place, do I have a new angle? The answer is yes, because the old and the new are not the same. So then I erase the old angle, which was the last angle, and then I write the new one. Then the last angle becomes, I load the angle into the last angle, and I'm going to good to go for the next time. Next time I come in, if the angle did not change, then I don't do nothing. I don't do anything, and the number stays the same. So I think I gave you a good idea of how we go about the display, which is same as 35, except that in presentation 35, I had a loop that made this arm circulate around and around and around. So instead of doing that this time, what we do is we just go to a particular angle that has been calculated by the magnetometer. And then we do the same thing, and this is new. We come in, and if the angle changes, then we erase the old one and we put the new one. Otherwise, we do nothing. In that way, we avoid the flickering. So anyhow, let's continue with the presentation. Let's start by looking at our test setup. So the test setup is going to be based on techniques we learned in presentation 34, which was the PCA9685 16-channel PWM controller. So what we're going to have is at our ATMEGA 328, there's going to be a joystick hooked up to it, which is going to be hooked up to ADC 1 and ADC 2. And I'm also going to have a potentiometer, which is going to be hooked up to ADC 0. Now, during presentation 34, we had this whole setup, except that now I added a potentiometer and I added an extra servo. So as I noted, we have our ATMEGA 328, we have a potentiometer and a joystick. Now, on the PCA9685, the 16-channel PWM controller, we're going to have 3 servos hooked up to channel 0, 1, and 2. Servo 1 and Servo 2 are going to be controlled by the joystick, and Servo 3 is going to be controlled by the potentiometer. And these 2 units, the controller and the microcontroller, I should say the PWM controller and the microcontroller, are going to communicate through the I2 bus. So let's get a picture of what this thing is going to look like. So on top, we're going to have our magnetometer hooked up right here. Next, we're going to have what I said, servo motor 3 down here, and this whole unit is hooked up to this servo, which is the servo 3, which is going to rotate, which means this whole thing is going to rotate. And I've called that the servo motor jaw control. Next, we're going to have another servo, which is going to make this whole unit go forward or off, which I've called the servo motor pitch control. And finally, I'll have this servo, which is going to rotate. It's going to roll about this axis. It's going to roll, and I've called that the servo motor roll control. So let's see how this is going to work, get an idea. So here I am rotating the potentiometer, and we can see how this whole setup rotates. You can see right there. And this is the magnetometer. Next, this is the what I call the pitch control. So as I move it forward, and you can see the magnetometer here, and move it aft, and this is pitch down. And then I have I'm moving the joystick back and forth, left to right, where this rotates. So and just give you some extra information. So this is going to control the motion of our test setup through these 3 servos and the magnetometer up here. And then the magnetometer is actually going to be hooked up to this area where I'm going to have a display which is going to display the rotation of the servo. So I rotate it with these controls, and then to this other portion I actually display what is that the magnetometer is sensing. So with that information, let's go ahead and continue with let's look at the code. Let's start by looking at the include files. The one thing that we added this time was the circle lines text.h. That include file contains all the code that we developed during my presentation 35 to draw circles and moving arms. The rest is similar to what we've done in the past. Now the I2C initialization of the I2C, TWI start, which is the I2C start, the I2C repeat start, and the I2 stop. These are exactly the same routines that I developed during my presentation 16, I2C serial communication. Basically what I did is I copy and paste those routines into this program. Next we have here the transmit data, receive with acknowledgement, receive without acknowledgement, transmit address plus read, and transmit address plus write. Now again, those routines are cut and paste from the programs that I developed in presentation 16, I2 serial communication. So I just cut and paste from those routines, and they work fine here. Next we have the routine configure magnetometer, which basically we use the way it works. We send the I2C TWI start, then we send the start plus write with the address of the magnetometer, which is 1E hex, and then I configure the register A, which is going to be normal mode, then I configure register B, which is going to be gain of 5, and then I set it up to continuous mode, which means that once I'm going to call the register 3, which is the first data register, is going to go ahead and send them all. And finally I go to the I2C stop, and then I wait 100 seconds. Next we have the routine magnetometer data. So what we're going to do here is we're going to get, as I noted before, we're going to get the X, Y, and Z data, and then we're going to send, calculate what is the angle that of the motion, which is what the magnetometer is going to tell us, and then we're going to transmit that data to the laptop and to the calling routine. So we do that by, I'll just repeat it, it's always good for you guys to look at it twice because it's the first time. So we have the TWI, the I2C start, then we transmit plus write, and we send with the address of the magnetometer, then we transmit the data which says, hey, we want to start reading at the starting at register 3, then we repeat the start, and then we ask for the data, which is the transmit plus read data, and we put of course the address of the magnetometer, and then the whole data is going to be transmitted. So we have the magnetometer X, most significant and least significant data. Next it's going to transmit the Z, most significant, least significant, and then the Y parameter, most significant and less significant. Now this is the sequence that is going to send it, so you have to make sure you get this correct sequence. Next, the parameters, the magnetometer X, Y, and Z parameters are 16-bit numbers. So what we need to do is we take the first, the most significant, and shift it to the left 8 spaces, and then we OR it with the least significant. And we put it, we do that magnetometer X. Here is a 16-bit resolution word. Next, we do the same thing for the Y and the Z. So now we have our three parameters, and next thing we do, we're going to do a little housekeeping like I noted before. We repeat the start and send the address, address plus write to the magnetometer, and we send the data hex 3, which is basically says, hey, next time we also want to read from starting from 3, and then we stop. Now after getting the data, we have to, what we need to do is we have to calculate our rotation in degrees, so the angle. So we have the arc tangent of y comma x, that gives us the angle in radians, and then we multiply it by 180 and divide it by pi to get the to get in degrees. Now we go between minus pi and plus pi, so if the rotation is negative, so that means that what we need to do is at 360. And once we do that, then we transmit the information to the laptop, and also we return that information to the calling routine. So next we have the draw circular rotation. Now this is all out of Presentation36 display graphics. The only difference here is that on the display graphic, instead of having an angle that came from the magnetometer, at this point I had a do loop that would just make the arm go around and around. So I'll just go briefly to this one. So so we have to calculate the x and y parameters, because what we want to do is we want to draw an arm that goes from the center of the circle all the way to the edge. We know what's the center right here as an input to this routine, and what we need is the location of the x, y, of where to of those coordinates. So we'll have a line between the center and the this edge of the circle at a particular angle. So first thing is we calculate our x and y, which is the position at the circle, which corresponds to the angle. That would be the center plus the radius time cosine of the angle, and the y is going to be y center plus radius time the sine of the angle in radians. I convert it in radians. And then we just draw the lines. We draw the line from the center to the edge, x and y. But what we do is we want the arm to be a little bit thicker. In one line it doesn't show very well, so we draw three lines that start at the same point, but they are a little bit off. So that would be x plus 1, x plus 2, and x plus 3, and the same thing for the y. So that gives you a thicker line. Then we wait 300 milliseconds, and then we go ahead and erase that line. Now, as I noted before, we're going to write the numerical value also. So we only write the numerical value in a, it's going to be on a box that is on the left that you already saw, and I only write it if the angle changes. And I already talked about this. I used the C function, which converts the numerical value to string in base 10. And I erase the old value, which is the one shown on the display, and then I write the new value, and then I update this that I load the last angle is going to be equal to the new angle value, and then we just go around and around. So let's go to the main program. So what we do is we just set the color black, and then we're going to initialize the ports, initialize SPI, initialize the display, initialize the UART, and we initialize the I2C. Next, we're going to draw our circles. first we fill the screen, so it has a color, and then we're going to draw a circle that is composed of four concentric circles. So they have the same. So the circle routine takes the color, the radius, and then the center of the circle. So they have the same center of the circle, but the radio is 86, 85, 84, and 83. So it's a little bit shorter radius of the three circles. So it shows a thicker. The whole circle is going to be a little bit thicker. Then I should take the line of the circle. Next, I have here I start with the message hello world, and then write the hello world, then I erase the hello world, and then I write the magnetometer GY273 on the display and just leave it there. Once I've done that, I configure the magnetometer. I draw a little square on the side where I'm going to put the numerical values of the angle, and then I get into my infinite tool loop. Basically what I do is I draw a circle rotating arm, so it's going to rotate the arm and place the angles in the box, which is what this thing was doing. So let's look at the output of the program. So before I start, so this is the little arm, you can hardly see it, but then the second shot I'm just going to concentrate on this area. But first I wanted to give you the overall picture. So I'm going to be moving this this knob, which is the potentiometer, which is going to make this unit rotate. And as this unit rotates, we're going to see how this arm goes around. At the display, the number shows up in this little box. But again, we'll have I'll show you two times this. The first one, this whole setup, and then I'll concentrate on this one. So let's get going. So I'm going to start moving the, and you can see how the arm is following the motion here, and the number is right there, but you cannot see it very well. So as I rotate here, the arm follows. Now this is 0 location 90 to 70, but the servo goes beyond the 2 to 70. So let's look at the display a little bit closer. So here we go. So you can see this should be actually 0, so that's 360, so it's very close. So then I keep moving it, and we get to 270 right there. And then as we move, we go back to 0 degrees, and then we go to 90 degrees. But the way I have this set up, the servo's moving beyond the 90 degrees. So we go to about whatever number I showed, I missed it. So here we keep the motion. We got the magnetometer. So the graphics are not perfect, but this is just to give you an idea how these things can be mechanized, or how you can do something, and all you would need to do is, of course, improve the techniques for the displays, which are many. So let's continue with the presentation. Okay, so let's so now what's left is the summary. So today in the presentation, I gave you a description of the magnetometer. Next, we looked at the data sheet. After, from the data sheet, we developed our framework. And then I showed you how to initialize the magnetometer, and we went through a sample program. So I would like to thank you for taking the time to spend with me. And I hope you've enjoyed the presentation, and I hope I see you next time. Thank you very much.